For topic 3, we're going to look at quadratic equations, okay, and the zero product principle. Some books will call this the zero product property. So if in class I call it the property or the principle, it's the same thing, okay? So the the quadratic equations, we already know what a quadratic expression is. So a quadratic expression, remember, so the quadratic expressions were ax squared plus bx plus c, where a is always the coefficient of the squared term, b is always the coefficient of the linear term, and c is always the constant, okay? So to go from a quadratic expression to a quadratic equation, we just have to do this one extra little thing, okay? So for us in this section, a quadratic equation is an equation that can be written in standard form as ax squared plus bx plus c, and then we just tack on equals 0, okay? Where a, b, and c are real numbers such that a is not equal to 0, okay? Again, we mentioned this in one of the previous videos, but if a is equal to 0, this term disappears because 0 times x squared is just 0. But in order to have a quadratic equation, we have to have a squared term. There has to be well, one squared term at least, okay? So we can't have a equals 0. B could be 0, c could be 0, that would be fine, but we have to at least make sure a is a non-zero real number so that we maintain that squared term, okay? Now, the form ax squared plus bx plus c equals 0 is called standard form, okay? And that is going to be a common theme. When we go to solve these equations, we need to start by putting them in standard form, okay? So the equation may not come to you naturally in standard form. Your job is to put it in standard form and then perform whatever method or whatever process is required to solve that equation, okay? So again, we mentioned this with the polynomials in a previous video. A quadratic equation is called a second degree polynomial equation, and it has two solutions. So that is going to be one difference here. When you're starting to solve these equations, you do get two solutions. Okay, so that's a little bit different. With linear equations, we just had one solution. Here we'll get two. Okay. Now, for example 3, this one's going to be really, really quick. It just says, write each quadratic equation in standard form. That means we want the squared term, then the linear term, then the constant, and equal to 0. And I will tell you this right now. You need to, at this level in your math career, you need to make sure the squared term stays positive. So arrange things so that the squared term remains your positive term, okay? So for part A, we have x squared plus 1 equals 2x. Well, we want to set this equal to 0. So in order to do that, I need to subtract 2x from each side. So on the right-hand side, when I do that, 2x minus 2x is just going to equal 0. So I've got the 0 that I desire. I just need to simplify the left-hand side. We want to keep our squared term first. We want our linear term second, so that's that minus 2x. And then we have plus 1. Let me move my equals 0 down a little bit. Looks kind of dumb. So this right here, this is putting that equation in standard form. These two equations are identical to each other. One is in standard form, one is not, okay? Now for part B, we have x squared equals 10 minus 3x. Resist the urge to subtract x squared from both sides to get your 0. That would not necessarily be incorrect, but for us, with the skills that we have and the tools that we have in our belt to solve this, we need to make sure that we keep the squared term positive. It's just going to make life so much easier for us, okay? So even though it's going to require a tiny bit more extra work, let's move the 10 and the 3x to the left. So I'm going to subtract 10 and add 3x to both sides. So when I do that on the left, I'm going to get x squared. We added 3x to both sides, so plus 3x. We subtracted 10 from both sides, so minus 10. And then what is that going to equal? Well, 10 minus 10 is 0. Negative 3x plus 3x is 0. So my right-hand side equals 0. Okay, again, for us at this level in our algebra, we need to just make the squared term positive. So keep it positive even if it takes a little more work, okay? Now that finally leads us to the zero product principle. Again, depending on the book, it could be the zero product property. I will generally call it the zero product property. Just know it's the same thing, okay? Now, in order to talk about this property is going to allow us to solve a quadratic equation as for us, as long as the a term is equal to 1. Okay, now you could use this to solve other types of quadratic equations too, but for us, we're going to use this when a is equal to 1. So we have to remember a few things. So we're talking about a zero product, okay? A zero product. That means two things that have been multiplied and equal 0. So how does that happen? Well, we have to remind ourselves that the product of any number and 0 is 0. So we could take any number, okay? So any number, let's call it z. And if we multiply it by 0, we just get 0. So if you multiply anything by 0, you get 0. So we have to kind of think of this backwards, okay? We have a product that equals 0. So that tells me at least one of my factors must be 0, okay? And that's kind of how the zero product principle or zero product property works. If we have a product that is 0, at least one of the original factors of that product must be 0, okay? So the zero product principle states if the product of two algebraic expressions is 0, then at least one of the factors is equal to 0. So we then go on symbolically to say if a times b equals 0, then a is 0 or b is 0 or potentially both. Okay? So this property is essential when solving quadratic equations. Okay? So let's get to it. Let's just practice it. Okay? So example 4, we're going to practice the zero product principle, okay? We have in part A, x times x minus 2. So those are our two factors. X is a factor all by itself, and then x minus 2 is a factor all by itself. And we have that they're being multiplied, and they equal 0. So in order to apply the zero product principle, we can take each factor and set it equal to 0 individually because at least one of those two factors has to be 0. So let's set them both equal to 0 and see what happens. So we're going to say, okay, x equals 0 and x minus 2 equals 0. Well, now we can solve. So x equals 0 is solved. We're saying, hey, if x is 0, x is 0, okay? But for x minus 2 equaling 0, what would that tell us about x? Well, if x minus 2 equals 0, I could add 2 to both sides, and that would tell me that x equals 2. So let's kind of just see what happens, okay? So let's check x equals 0. We're going to take our original equation. Anywhere we see an x, we're going to plug in a 0. So we get 0 times 0 minus 2 equals 0. Well, I get 0 times, well, 0 minus 2 is negative 2. But what is 0 times negative 2? Well, it equals 0. So by letting x equal 0, we get a product that is truly equal to 0. Hold on, my computer's dying. All right, now let's check x equals 2. So if we take that original equation and plug in 2 for x, we will get 2 times 2 minus 2 equals 0. Well, 2 is just 2, but 2 minus 2 is 0. And what is 2 times 0? Well, it's 0. So by taking this factored equation and setting each factor equal to 0 and solving, we get the two solutions for this equation. If we plug in x equals 0, that satisfies the equation. We get a true statement. We get that 0 equals 0. If we plug in 2 into the equation, we get that 0 equals 0. We get a true statement. So x equals 0 and x equals 2 satisfy the equation. Therefore, those are our two solutions. Okay, so this zero product principle allows us to solve a quadratic equation as long as we can factor it. Okay, so let's look at this next example. So for part B, we have 2x minus 5 times x plus 4 equals 0. So we do have a product equaling 0. So we can apply the zero product principle. That just says we take each factor and set it equal to 0 individually. And if I have 2x minus 5 equals 0, I would need to solve for x. So I could add 5 to both sides. That gives me 2x equals 5. And then I could divide both sides by 2. And 2 divided by 2 is just x because 2 divided by 2 is 1. And then 5 divided by 2 is just, we're just going to leave it 5 halves. Okay? Now let's look at x plus 4 equals 0. If I have x plus 4 equals 0, I can solve for x. So I would need to subtract 4 from both sides. I don't know why I couldn't put the sign there. There we go. And 4 minus 4 is 0. X plus 0 is x. And then 0 minus 4 is negative 4. So let's check both of these values to see if they satisfy the equation. So we get, let's check x equals 5 halves. So we get 2 times 5 halves minus 5 equals 0. And then, oh, don't do that. And then we've got 5 halves plus 4 equals 0. And then we're going to check second, x equals negative 4. And there we would get 2 times negative 4. I can't write to save my life today, you all. We get 2 times negative 4 minus 5 times negative 4 plus 4 equals 0. So let's see what we get here. Now, the first one's going to be kind of a little bit more difficult. So I'm going to start by checking x equals negative 4 first, just because it's going to be a little bit easier to work with. So we get 2 times negative 4 is negative 8. And then negative 8 minus 5 is negative 13. Negative 4 plus 4 is just 0. So then negative 13 times 0 equals what? Well, it equals 0. So we get 0 equals 0, which is true. So that tells me x equals negative 4 absolutely satisfies this equation. It gives me a true statement. Now, 5 halves is going to be a little bit more involved, okay? So right here, if you're looking at 2 times 5 halves, we could think of this as 2 over 1 times 5 over 2. That would just be 2 times 5, which is 10, over 2, which is 5, right? So 2 times 5 halves is really just 5. So I get 5 minus 5, and then I get 5 halves plus 4. So 5 halves plus 4. We got to think of a way to rewrite this. So 5 halves plus 4 over 1. We need a common denominator, which we don't have currently. So we would need to find one. So the common denominator is going to be 2. That's the smallest number 2 and 1 go into. So I would need to rewrite 4 over 1 where it has a denominator of 2. So I would have to multiply top and bottom by 2. So that would give me 5 halves plus 8 over 2, which is 13 halves. Okay, so I'm going to replace this with 13 halves. Okay. And then 5 minus 5 is where things are going to get easier for us. What's 5 minus 5? Well, that's just 0. So we get 0 times 13 halves equals 0. And what is 0 times anything? Well, 0 times anything is 0. So again, it took a little bit more work here, but we get a true statement. 0 equals 0. So both of these values satisfy the equation, meaning when we plug these values in for x, we get a true statement. So we can say that the solutions to this equation would be negative 4, comma, 5 halves. So you're still going to use the set builder notation that we used earlier in this chapter, but you're going to put 2 solutions for x inside. So just don't put the x, just put the actual numbers for x inside curly braces, and you generally put them in order smallest to largest. I'm not going to lose my mind if you don't put them in the correct order, but just make sure both of your solutions do go in those curly braces, okay? So that's the zero product principle. You know, you may have to watch this video a couple times because we're getting into some, a little bit deeper algebra, but hopefully this isn't too bad. So first, there we go. First, make sure you know how to put your equations in standard form. And again, for us, make sure the squared term stays positive. It'll make it easier on you, I promise. And then make sure you know how to apply the zero product principle. In the next video, we're going to learn how to solve quadratic equations by factoring.